Okay, well, I'm going to kick things off here, so feel free to stop me if you guys have questions at any point. So today we're going to be talking about Baratine, operational service views. So originally when I had this slide started, I had began writing about some of the accolades of what the architecture tries to do. And what I realized as I sort of worded it together was, you know, Baratine is really described as the same accolades as SOA. So if you recall the original implementation, the original words that SOA used, explicit boundaries, loose coupled, services agreeing with a contract, a schema, but not sharing an actual class. All of those same words are now really rebranded as microservices, right? Microservices can be called SOA 2.0. So rather than looking at the actual words to describe the architecture, I thought it would be more helpful to look at what the underlying architecture of Baratine is and why it is different than the architectures that are out there. Because if we're going to start building microservices and implementing SOA, the question that arises is, are we going to use the same tools and end up with the same problems that we've had previously when looking at operating on data services? So what we have here is a high-level overview of what a Baratine service is. And a couple key concepts here within a Baratine service. So from a developer standpoint, much of what you see here is hidden, and a developer is really only going to see the API and the service itself. Baratine, what we do around that is we enforce a strong encapsulation boundary. So within a service is bound by an inbox, and within that service itself, a service is single-threaded. So only operating in the service itself is a single thread that's known as a service thread. So it's an efficient and lock-free inbox that does automated batching to the service itself. And inside the service, because it's only operated on by a single thread, the application code can be single-threaded. So we're inside of a Baratine service, we're not going to be using a concurrent hash map, and we're not going to be writing synchronized blocks because operating within the service itself is only a single thread. So persistent services load and store their data to a document-style key-value database. So a service is backed by its own portion of the key-value database, document-style database inside of Baratine. So services use their data in memory. Loading and storing is transparent to the developer. Data is loaded once, usually in memory, and it's not evicted until it's LRU'd. And the final point here about a Baratine service that I do want to talk about is that services own their own data in an object-oriented model. So it's just a highlight point here that within a service itself, only the services thread is ever going to be modifying that data. And because of that, there's no locking, there's no blocking, and there's no actual synchronized portions needed within a Baratine service. So a final point here before we look at a few demos is database persistence. So the in-memory persistent services are built into Baratine. They use an asynchronous high-performance database that we've called Kraken. We have an application service operates on its data in memory, which does improve performance and simplify code. So after MySQL, we've seen the rise of NoSQL databases, and really that's just pushing the data into memory because we know that in-memory is the fastest space that we can operate. So the third point there is that data is automatically loaded and saved into the internal document database as part of the assets lifecycle. So I could go into more detail about the architecture itself, but with the time we have, I thought it'd be useful to look at a few use cases of what Baratine looks like. So the first use case we'll look at is an API engine. Many people are familiar with REST services, and what we get here with Baratine is that a Baratine service can operate as a REST service, and within the Baratine environment, what you're going to be automatically guaranteed is that a service will be highly efficient, a service will own its own data, so a service can shard based upon its own data. Data shards automatically. And we can really look at getting prototypes of solutions, REST services, up extremely fast. So to sort of finalize this point and go over it a little more clearly here, I have an application. It's a simple REST service here. So Baratine's now up and running. I can go here and go to the port 8080 where it is running, and what we can see here now is that this is a REST service. So on the back end, what's actually happening is we have a simple hello service, and it's the hello world, and the update's going to the back end. The back end is simply the Baratine service, and it's returning that value, and that's what you're seeing on the front end here. So updates are easy, and updates are also quick. So a point here, though, is that we talked about the persistence of Baratine. Well, if we kill the application, so if we kill the application and reload the server here, we've got nothing going on. I'll rerun the application. Once the service does come back up, what you'll find is that the persistence is still there. So the previous value that was stored in Baratine is actually persisted and saved to the internal document and back to disk. Now, what does the actual service itself look like? Well, we can see what the service looks like.
So you have a single instance of this guy, so it's not parallel. Like if you have 10,000 clients, they all go funnel into a single thread that sequence them all, or if you have...
That is correct. So the services are backed by the inbox, and within the requests are going to be batched over to the, it's a ring buffer similar to the disruptor. So similar to how Node.js gets its fast performance and Vertex gets its fast performance, you actually get better CPU cache utilization on a single thread than what you're getting when you try to parallelize. Because when you're working with the data, as Amdahl's law did show, that you're always going to be limited by the portion of your code that has to be done in serial, that has to be done in order. So when we come to the portion of doing a code modification, a data modification in order, the fastest way to do that and the most efficient way to do that is by using a single thread within that CPU. So here's the actual class itself, and let me just zoom in so you can see it here. So the results are asynchronous. What's needed to persist the service is simply the asset modification here and an explicit modifier here. So what we're saying is on every update, we want to go ahead and make sure that this service is persisted to disk. Result.ok, that is our callback. So Baratine does do asynchronous as well as synchronous services. When you're dealing with asynchronous services, you're going to be using the Baratine result. And we simply tell the result.ok, and what that goes ahead and does is it tells the request that it's finished. So that's a simple example of what a REST service can look like. And we can look at one that's a bit more involved here with a bookstore. So a bookstore, as you know, is one of the typical Java applications that people do run and people do show for how they can actually, how a framework can be used. So if I look currently, what you see is I do have one book that's entered into my bookstore already. I will show you the code for that. So I can enter a new book, so I can say I am the author here, and this is my DevOps demo. So I can author a title. If I check the list, it goes in. 789, Sean 2, DevOps demo 2. So I can see that I'm adding actually to the internal database within Baratine. The problem currently, though, is that if I were to kill this application and restart this, well, let's reload this. Okay, site cannot be reached, and restart this application. What you're going to find actually is that the data is not persisted currently within the database. So the question would be, how difficult would it be to make our bookstore persistent? Well, with Baratine, because the service is owned by a single thread, and it's very easy for us to then back that service's data into a store. So what that means in this case is I can open up my file here, and simply with an asset and with a explicit modify on our post. I'll save that. What this is going to allow me to do now, let me kill that. What this is going to allow me to do is persist the data to disk with two simple annotations. So I've got it rebuilt. Let me go ahead and bring it back up. Okay, so it's back up and running. We see the current list here. I'll add one book to it. Again, this is the Devoxx demo book that I'm authoring currently. I will add it to the list, and we see it's in the current list. Now when I kill the application, and I can reload my local host, see nothing is there, I can bring up that application again, and with simply just those two annotations, my data is now safe and persisted within Baratine. So moving back to use cases of Baratine, let's look at the differences of what we're talking about when a thread's operating within a service in Baratine. So traditionally, a bookstore REST service, the way it comes in. Now, you don't actually have the stub. So the green marker there is what acts as the stub. But really what happens is all the requests do come in. When data needs to be modified, you either must write a synchronized block around that portion, or the request itself will go ahead and lock that field while that field is updated to the database. So there's no thread ownership. Multi-threading can then result in, let's say your database is taxed and you cannot spin up a thread at the back end. You can bring down an entire application server, entire stack, just by having a lot of requests come in. And we actually are makers of the Resin application server, which is a multi-threaded server. We've been supporting it for years here, 20 some odd years. So that is why we've sort of started to see a new model where within Baratine, all of the requests will come in and get queued to a thread lock efficient inbox. Within the service thread itself, the operations are done in memory. There's going to be no locking and blocking, and we have single thread ownership of the data. So there's no need to ever introduce a cache in front of the service. There's no need to extract the data outside anywhere of the service, because the data is owned by that service. The data is operated only on a single thread, and that gives us great actual performance. So when we look at an implementation of REST Easy, JAX-RS implementation, REST Easy versus Baratine, we're getting over 2 times performance. We know that Baratine can be scaled to match the cores on the CPU, so we can be very efficient with the actual CPU's, the cache of that CPU. And we also, as we did see, that persistence is added with single annotation. Yes, so it's single-threaded, but one of the annotations that I will introduce, if you wanted to scale per core, what you could do is there's a workers annotation that will allow you to spin up threads to the back end of the service. So it's the same way that we are able to talk with JDBC, because JDBC is blocking. So there's a separate annotation that we can use if you wanted to scale out per core, that you could have four threads spun up on a 4-core server. So each core within the server, each core within the CPU is utilizing 1 thread, very efficient. When we look at in-memory I'm sorry? Right, so the workers annotation is a way to integrate with the current traditional architecture that is out there. When we use Baratine and we scale out Baratine, you're scaling out Baratine based upon the CPU's box itself, so you can, within a Docker image, establish the CPU power you want to give to that Baratine service itself. And from that, we're going to be very efficient when we're working on a single thread. So it does sound like a single thread is going to be less efficient than using a multi-threaded CPU. But what the data shows is that if we look at a database on the same network and we look at traditional servlet versus in-memory, and this benchmark was ran with 1 update per request, the data was persisted to MySQL, Baratine is a lot faster because it's removing the database from the critical path. So everything is in memory, and the first request is actually slower than the second request because of the CPU cache and that utilization of a single thread. So there's actually a great white paper out there. It's called Scalability, but at what cost? And cost is what they define as the configuration that outperforms a single thread. What they basically come to realize within the paper is that oftentimes the overhead introduced by a framework means that the benefits of scaling out horizontally, you rarely do you achieve the performance of a single thread efficient implementation.
Last question, how do you back pressure?
So we do back pressure based upon the inbox itself. So the inbox is journaled, and the request will fill up. So if your memory reaches its max because of the you have that many requests coming into the inbox, but we're limited by the hardware of the machine itself. So it's rare that we would reach the case where an inbox, a service will reject requests. Services don't reject requests. They journal the request into the inbox, and they spin through that inbox, and it's a very highly efficient manner of answering the actual request. So the in-memory operations portion is that data is loaded only once. We have large data sets that will shard by themselves. Again, that is because the service is the only ownership of that data, so we can easily shard a service based upon its data and continue to do operations as we scale out to a multitude of end servers. We have write-through in place, so Baratine does save the fields of an asset to an embedded, fully reactive document database, so it's an append-only style database that we do use. And we have journaling for reliability and failover. So the inbox is backed by a replayable journal, and that is how we're able to sort of recover the state of a service if ever a service does go down. So when we look at the performance of Baratine, our continuation asynchronous performance is a lot better than, is always consistently better than our future performance, so the wait. We get about 9 million messages per second and 4 million calls per second when we're using the synchronous version of Baratine. So as we scale out to the number of clients here, though, what we realize is asynchronous performance drops but stays well over 2 million calls per second. And how is that possible that Baratine is able to maintain such high performance as you scale out to more clients? Well, it's able to do that because Baratine does implicit batching. So you're getting better performance as the number of clients increase because the batch is a lot more efficient, the CPU cache is there, and that thread that's running and answering the request is able to maintain performance as Baratine is used here. So if we look at another use case of a Baratine service, it's what I talked about earlier, so a microservice. So an auction microservice, and when we talk about the reactive manifesto, services must be elastic, they must be recoverable, and they must be scalable. The auction service that I will demo to you is impressive because each actual service that you're going to be seeing can be scaled out individually. So we could have separate servers for our user service, we could have separate servers for our auction service, and because of this, because each service is going to be its single owner of its actual data, it allows, it inherently is going to scale out to the actual end users and end servers there that you might be using. So let's take a look at this in action. So all right, looks like it's up and running there. Oops, looks like I did not kill this one, so let me close this port. Now let me get it up and running. Okay, so what we have here is a auction service similar to what eBay might be. I can have a name here. Let's see, I'll just be user1 and password 123. If I try to log in, the login fails. We first create the user. We see that the user is now created down here. We can go ahead and log in. The login is successful. I can make an auction here. Trucks, we'll start the bidding at 10. And then when I go ahead and search for my auction, I had made an auction named trucks earlier. We can see that you can bid, and bidding takes place and is being answered by the actual inbox of the service itself. So because the service is ordered, the inbox is ordered in serial, what we're able to do then is allow millions of requests to come into this service, and the service then takes care of ordering those requests. What we have running in the background of this auction service is actually a timer. So as you can see, that the state has gone over to settled. Why is the state settled? Well, the state's settled because the timer service, what it does is it first verifies all the requests coming through. Once the timer does hit its 10-second limit, which is what I've set it to right now, it will automatically go through the refund process, it'll go through the PayPal implementation process, and it'll go ahead and actually run those portions and save them to persist them to the database inside. So as you can see that the bids are going on, in the back end we see that the bids are being accepted, but after 10 seconds we do see the state actually goes into a settled nature here. So the code for this auction, we can look at it and see that, so these are the actual files we have implemented in a full-blown sort of microservice, and everything here is within Baratine. So we're doing database service, we're using Baratine's event service, we're using WebSockets as the communication, and we're actually doing verification through PayPal. We have the user settlement and the settlement transaction state. So we're doing every portion, and we've really just prototyped this as a way to show how you can use Baratine on full scale for full scale deployments. So what we're looking at, though, when you take a look at one of the actual classes here, everything is internal. We're only using, we have a service here, our PayPal service that we're injecting for the auction settlement. So we have bids that come in. When the bid is settled, we do call the settle impl. Status is okay. Here is where we are actually going ahead and settling any of the requests that might have come in, might have been bid while the state was changed from open to closed, and then to settled. So we go through 3 actual changes there. It happens a little bit too fast to see it on the screen, but the auctions are actually going from open to closed to settled. And what that does at the very end of having hit the settled is anybody who was bidding on it, let's say if this was a live auction on eBay, they would have actually had their refund come through to them if the state was closed and the bid was somehow accepted. Because everything is journaled and backed by a journal, we have a very reliable way to replay any of the information that's come through to the service. And it allows us to prototype these sort of solutions on a large scale and then scale them out, with scalability really being an afterthought. Because we know that we've moved the database out of the critical path of operation, we're allowed then to focus just on the code itself. We have the ability then to put our service live into the cloud. Recently we were on site with a company who was looking to introduce a new mobile selector in front of their application. They wrote it in PHP, and it actually ended up bringing down their entire application stack. Now, with Baratine, if they had used Baratine, what they could have done is put that service up, simple REST service, simple selector, and known that the performance is not going to degrade their application, because we can build jars here and not WAR files. So Baratine can be used as a library, it can be used standalone, or it can be embedded within the current architecture that you would be using now. The thing that is different and imperative to understand here is that as you build out services, you know that a single service is never going to be responsible for bringing down all of the other services that you do have, because they are only talking JSON. So you can integrate with every language that does speak JSON, and you can do so without worrying that your new portions of your application that you're building out is going to be detrimental to the data it's needed to operate on. You can stream analytics off of a service very easily without actually having to worry about some of the portions of of high performance within the application itself. So that does put me 5 minutes over my time here, but oh, sure thing. I was just going to open it up for questions. So this is part of the settlement service here. So what we're doing is we are, which one are you looking at here? Okay, this one here. Yeah, right. So what it's first doing is it's getting the data from the auction. So the auction data is owned by the auction service itself. So it first is actually going ahead and getting that data, setting the auction, and then what it's doing is using a separate thread to go ahead and charge the credit card. And then what you're seeing there is two portions. So we have a winner and we have the auction. So we have to get first the auction data itself, and then we also have to get the winner to see who was the actual winner and who should we charge before the payment structure there. So in parallel there, it sends out two requests, waits for the auction data to return. Once we have the auction data, which does include who was the actual winner, we take that and we're charging that end user with. So
you fork two threads to do these two operations in parallel?
Correct. Correct.
Okay, so when fork join is waiting blocking for those two.
Correct. So we.
So it's not a sync.
Well, for portions of the code right here, what we're doing is we're making sure that the winner is charged based upon who has won the auction. And since the auction is the only owner of its data, we do have to send out a request to the data, come back to the auction owning service, get that actual winner data back, and then we can go ahead and charge it. So, but this method itself is not actually a blocking method. And that's based upon the idea that within a call to an actual service, what we're doing is we're giving futures and continuations to the calling in threads. And so the thread that calls into the inbox is then off and doing more work in the background. These threads, once they complete, pass the result along, and we have a fully asynchronous portion of the data that's been retrieved and then used within the application itself. So it's a bit of a... Correct. So what we have when we do work with portions of the code is you will have portions, again, that will be done in serial. So we couldn't actually charge a user without knowing who has won the auction itself. So it's a way that we've chosen to structure this application and show that the separate entities in owning data are owned by different services itself. So just going back to this image here, because the auction data is owned as an outside service, we need to verify that, get that actual auction data, and from that auction data, we're pulling the last bid's winner, and we're charging that winner based upon there. Okay, and were there any other questions? Great. Well, thank you guys for showing up.